Hello everyone, welcome to my channel AQDG Space. Today I have come with the lecture about operators. Before going further, the basic question for today is what is an operator? We will take an example of the numeric operation of 2 plus 3 or 7 minus 6. When we view it in the lines of programming, we will find that the plus and the minus signs that are in between the two numbers, they are termed as the operators, while the two numbers are termed as the operands. Together, the operator and the operands make up an expression. So in C, an operator is a symbol or a sequence of symbols that represent a specific operation to be performed in one or more operands. It is used to manipulate data and to perform computations within expressions. Now that we know what are really are operators, we will talk about the different types of operators. The first one being the arithmetic operators, which is further divided into either unary or binary. As the name implies, unary are those arithmetic operators that works on a single operand, like the plus plus or the minus minus. The plus plus are known as the incrementer, while the minus minus are known as the decrementer. That means any number, any single number, when is applied with a plus plus operator, that means a one value would be incremented in the original value. Whereas a single operand is applied a minus minus operator, that means that one value would be decremented from the original value. Moving on to the, for example, moving on to the example, if A is equals to 10, then pre-incrementer plus plus A would be that first it will be incremented, then it will be assigned the value, that is the value of A would now be 11. Whereas post incrementer means that first it will be assigned the value A, that is 10, and then after that it will be incremented to plus 1, that is 11. So for a pre-incrementer and a post-incrementer, it works likewise. Moving on to the binary arithmetic operators, these are those that are basically the connecting operators between two operands. Like in the previous example, we learned 2 plus 3. Likewise, 2 minus 3, or 5 divided by 10, 5 multiplied by 10, or 5 modulus 10. This percent sign is known as the modulus, which gives the remainder of the after dividing the two numbers. Let's take an example. Example 1, the A is a variable of the type integer. It is assigned the value 10. And there is another integer which is assigned the value, the name B. So B is assigned, B is equals to A plus plus. Initially, it will be assigned the value A and then it will be incremented. So first 10 value would be assigned to B, and after it's being assigned, then it will be incremented to 11. So that means the output that we should be getting is that A is equals to 11 because now it is incremented to 11, whereas B is equals to 10 because the original value A was 10 and that was assigned to the value B. So B will remain as it is because it would be assigned the value of A. It is a post incrementer, whereas A will be incremented to one value because now after being assigned to B, it has now incremented itself to a value 1. Moving on to another example. Here A is assigned the value 10, integer B, and we are using pre-incrementer A, which is assigned to B. So the output to this is that A would be 11 likewise as it was in the previous example, but this time B would also hold 11. Why is that so? Because first A would be incremented, that is the value of A would become 10, 11, and then it will be assigned the value B. This is the difference between post incrementer and pre-incrementer. Few detailed examples from the binary operators. Like in the first one, the plus sign adds two operands like A plus B is equals to 30. Minus sign subtracts second operand from the first like A minus B can be minus 10. Multiplication sign multiplies both the operands. Division sign divides the numerator by the denominator. The percentage sign is the modulus operator and the remainder after an integer division. So when one number is divided by another, the remainder of the division would be represented by the modulus. Plus plus is the increment operator, increases the integer value by 1 that we already discussed in the unary um, operators, plus plus and minus minus. Relational operators. This is the next type of the operators that we discussed before. These basically show the relation between the two operands and returns a Boolean value. That is, it returns either a true or a false. For example, a double is equals to sign will give a true if both the operands have equal value. So they are basically working on two operands, unlike the unary operators, but they are returning the true or the false only and not any numeric value. Exclamation sign is equals to is actually a not equals to, which gives true if both operands are not equal. Greater than sign returns true if one operand is more than the other operand or left operand is more than the right operand. Lesser than sign gives true if left operand is less than the right operand. Greater than equals to sign is true if left operand is more than or equal to the right operand. That means it covers both the conditions, either it is greater than or equal to the right operand. And similarly, the less than equals to gives the true if operand is less than or equal to the right operand. Let's see an example of relational operator. For example, if you have the program where a and b are two variables that are of integer data type and are assigned values 10 and 12 respectively. Now, when you print their values, consist using the relational operators, that whether a is equals to b. So a has a value 10, b has a value 12. That means they are not equal. That means that the relational operator here will give a false. So person D should be giving the output 0 because 0 is represented by a false. On the other hand, considering the second printf, a is lesser than equal to b. Here, 10 is lesser than 12. Not equal to, but yes, it is lesser than. So it is basically satisfying one of the two conditions of the relational operator. That means it's true. So the person D of printf should be representing, returning a value 1. As you can see in the output, the first one is a 0 and the second one is a 1. So in this way, the relational operators work. Operators. They are used to connect multiple conditions together or to reverse the logical value. These also return the Boolean value. For example, the double ampersand sign is represented as AND, which gives us true if both the operands are true, else it will return a false. Second one are the OR operators represented by two single lines. They give us at least true if at least one of the operands are true. And the exclamation sign is the not, which gives the opposite of the logical value of the operand. That is, if the logical value is true, it will return a false. And if it is a false, then it will return a true. So basically, logical operators are used to compare basically connect two different conditions that are returning the Boolean values already and then compare both of them together and to give the final result. Let's consider an example of a logical operator. Here the two variables we are proceeding the same value, the same example that we used in the previous operator, but here we have integrated the logical and ampersand sign or the logical AND operator, which would be true only if both the conditions are true, at else it will be a false. So in the first one, the condition is false, but the second condition is true. So since both the conditions are not true, it should be returning a false. Is the assignment operator, which as the name implies are used to assign a value to a variable. For example, an is equals to sign assign the right operand to the left operand. A plus is equals to sign First, we'll carry out the sum of the two operands and then assign that sum to the left operand. Minus is equals to sign will first perform the minus operation or difference operation, and then it will assign the result to the left operand. Similarly, the multiplication is equals to sign will first conduct the product of the two operands and then assign it to the left operand. And the division is equals to sign will divide the two operands and will assign the answer to the left operand. We will discuss the examples in detail in our coming slide. We will consider here the example of assignment operator in which we have two variables. One is ANS, which is a value of value data type, which is given the value 10, and another is B of the same data type, which is given the value 12. Now we will perform the assignment operator. ANS multiplied is equals to B. As a result, the ANS value would be multiplied by B. We get 120, and the same value would be then saved in the variable ANS. So the 10 value would be overwritten by 120. So the printf that will give the output of 120. This is basically used in order to prevent the clogging of too many variables for a single operation. As you can see that in this, three variables are not used. Instead, only two variables are used to serve the purpose. Okay, the situation is that if an equation consists of many different operators, we have yet to decide which operator should be performed first. Regarding that, we have the operator's precedence. So going up from the topmost level, the first one is that you have to consider the brackets, the operators in the brackets first, then the unary operators, multiplicative, additive, bitwise shift, relational operators, equality, and then bitwise and. So this goes from top to bottom. This is the precedence of the operators. Considering an example where an equation is given and the values are given above, where A would be considered as 10, B as 6, C as 8, and D as 7. So first we will, according to the operator precedence, we will first consider the operators in the parenthesis, that is C multiplied by A. We return a value 80. Then after that we will go for the multiplicative operators, that is B multiplied by A. We got the value 60. Then we moved on to the modulus sign. We got the value 60 again. So A plus 60 divided by 2. First modulus sign. Then we go for the division sign. 60 divided by 2. We get 30. And then we found another modulus sign after that. So we are going to perform that modulus again. So it was A plus 30 plus 7 minus B. We have now the additive operation. So we are going to go from left to right towards the additive one. So first we will perform A plus 30, which is 40, then 40 plus 7, which is 47, and then the minus sign minus B. In the end, we get the value 41. I hope students that you understood whatever was being taught in the lecture. Here is a small activity that I need you to do in order to make sure that you understood the entire presentation. Please go through this activity. In case of any ambiguities or any confusion, you're always welcome to leave a comment in the comment section, and I'll be glad to reply to it. Don't forget to like, subscribe the video. Hope to see you very soon in our next lecture. Thank you.